Today we're going to discuss Leetcode problem. This video is one of the many videos that we'll be doing over a period of time, and this problem actually appeared in bi-weekly contest which was conducted recently, and this is Leetcode problem number 2191. Sort the jumbled numbers basically. So the problem statement goes like this, you have a mapping. Basically it's a different number system, basically given a 10 digit, right? So 0 1 2 3 till 9. There is a sort of a rearrangement in terms of how those digits appear, right? Basically given a set of numbers and a rearrangement in the number system, you have to find out the sorted order of those numbers, which is a non-decreasing order, I would say. And there could be cases where both the numbers are of same value after conversion. So in those cases you have to maintain the relative order as in the original array. So without further ado, let's try to understand how we can do that, right? So basically, given a number, let's say 991. So 9 meaning we have to identify what's the ninth position in the given mapping, right? So the ninth position here would be 6, right? So it's a zero-based indexed mapping. It's a zero-based index array, so the ninth position would be 6 here, and the number would basically turn out to be 6 6, and first position is 9, right? So 669 is the number, and then there is 338, 3 meaning the third position is 0 0, and the eighth position meaning 7. So 007, essentially it's 7 basically. And then there is 38, which is again 7. So if we maintain the relative order, it would become 338, 38, and 991 basically, which actually translates to 007, 07, and 669. If you see in that particular order, those are properly sorted. And one other thing we have to keep in mind is the constraints. Every number is a positive number, which ranges between 0 and 10 power 19, and the length of the array could be between 30,000 numbers, right? So till 9. So without let's understand the approach. It's more or less an implementation instead of algorithm or a proper data structure problem. It's more like how we'll implement a specific scenario, right? So all you have to do is basically convert an initial number to a scrambled system number, right? So in this case 991 would become 669. So your solution should cover that approach, and once that numbers are in place, all you have to do is sort those numbers and return. So let's check the code quickly, right? So basically once you have a sorted array, you're supposed to return the original numbers instead of the transcoded numbers, right? So if it is 1 2 3 in the initial array, it would again be 1 2 3 and not a different number which is after the conversion. So to ensure that, we have to maintain a track of what the number is before and after the conversion, and also to maintain the relative position of those numbers. You have to sort of keep track of index as well. It helps if you keep track of these variables. So I've defined an object basically which would track these numbers given a particular number, right? So And so basically you start iterating through a bunch of numbers which are given to us, and we'll try to encode that number given the mapping. So the encoding function would more or less look like this. So given a number, right, so 991, let's take an example of this one, let's say this one, right? So this is 338, and in the numbers I will also copy this one. Right, so 338 would actually map to 007, right? So how did we come up with that? Given a, but basically let's try to implement that conversion, right? So we have a mapping. We started a particular digit from the right. So here it is 8, right? So how do we extract 8 from the number? What you can do is basically divide the number by 10, and the remainder is your digit. And for the next iteration you have to cut down the number by this digit, which basically is getting done here. And you basically don't have to do this since all the number is already an integer. So you take 8 and given result is 0, right? So after conversion it would be 7. 0 into 10 plus the map digit. So the digit here is 8. So 8th position here is 7. So it will become 0 plus 7. So initially it will become 7. And in the next iteration you see that 3 will be mapped. So the third position is 0. And 7 into 10 plus 0. It will become 70. And then it will become 700. So we got a number which is in a reverse order. So what we have to do is reverse that number to get us the proper order of the digit. So this thing actually helps in doing that. What we are trying to do here is basically convert the number into a string and reverse that string and convert it into a list, so that we'll be able to get back a string again. Yeah, so this is an iterator, and then we made it a list and joined it to get back our required value. So once the encoding is done, you have a bunch of number objects which we created by using this constructor. And now the task is to sort the numbers, right? So for sorting, we implemented a custom comparator function because we have multiple dimensions on which we wanted to sort, right? So sorting in general, the custom comparator in general looks like this. Like if the converted number is not matching, it means like if n1 is less than n2, then return -1, else return 1. So this is the requirement for compare CMP2 key basically. So if it is less than, you have to return -1, greater than, the other next condition would be 1. One condition will return -1, whatever order you want to preserve, and the other condition will return 1 basically. So if the numbers are not equal, we'll try to see if one of them is smaller, otherwise we'll return the other one is bigger. If they are equal, which in this case we'll try to preserve the relative ordering, which means we just have to compare the indices of those numbers basically, and by default we are returning 1, which is to preserve not preserving the order basically. So that's how it is, and basically we can test it against the given example test cases. That will basically, given these test cases, this is, I ran it, and this is my result, and that's what expected as well. Yeah, so that's about for the video. Don't forget to subscribe. We'll be doing these videos over the time, like after every contest we'll try to create a video for any questions that are little trickier to solve, or probably most of the guys couldn't solve also.